Okay, let's do a simplex method example. Here we'll use this Dakota furniture example. Pause the video, read through it on the handout. See if you can set this up. What are the variables? What's the objective? What are the constraints? Go ahead and set this up. Okay, this one's similar to Geppetto's problem. We have three products and we need to choose how much. So I'll call my three decision variables XD, XT, and XC. And we've got limited amount of resources for the amount of lumber, finishing, and carpentry labor that we have available. So we need to figure out how many desks, how many tables, how many chairs to make. Okay. Looking at the objective, here are the essentially revenue that we get. And in this case, we're just maximizing revenue because I guess all of our resources have been sunk costs at this point. We already have the lumber, we have the finishing and carpentry hours. We're maybe already paying those employees. And so we just want to maximize revenue at this point. So our objective is that we want to maximize here. I'll say Z equals 60XD plus 30XT plus 20XC. Okay. And then we're going to have this first constraint. It tells us how much lumber each of these requires, and as well as how much is available. And so 8 times XD plus 6 times XT plus 1XC has to be, I'm going to kind of leave a little bit of space because I'm going to do a little bit of eraser magic here. That has to be less than or equal to 48. Then we're going to get 4XD plus 2XT plus 1.5XC has to be less than or equal to 20. And 2XD plus 1.5XT plus 0.5XC is less than or equal to 8. Okay. Let's go ahead and change these into augmented form. We're going to introduce slack variables. All of these are less than or equal to constraints. So we're going to introduce slack variables. This first constraint has to deal with lumber. And so I'm going to add plus SL, and I'm going to change this into an equal sign. Okay, so SL being the slack for lumber. Let's do the same things with the other ones. So the second constraint is for finishing. So we'll add a slack variable there and change our less than or equal to into an equality. And then SC, change that into an equal to, and there we go. So those are each of our constraints in augmented format with our slack variables. Let's go ahead and assemble this into our Tableau. So, and I'm going to kind of line this up over here so that I kind of put as much on the left-hand side. I'll use the right-hand side for notes, and we're going to try to kind of have our tableaus kind of just go down the left-hand side of our page. So let's see, we got Z, move this over just a little bit, Z, X, D, X, T, X, C, and we're going to have slack variables SL, SF, S, C, and right-hand side. Okay. Okay, let's copy this over to here. The top row goes 1. I'm going to move these to the other side of the equation, leaving just 0 on this side. And so they'll all become negative as I bring them over. There's no slack variables in that objective row. and there's no value, no number over here, and so we're left with 0 on the right-hand side. There's no z's in any of the other equations. And then copying this down, we get 8, 6, 1, then 1 for SL, 0 for SF and SC, and 48 here. 4 to 1.5, and then SF shows up, but none of the other slack variables. 2, 1.5, 0.5, 0, 0, 1, 8. Okay, what you'll notice is this part here was exactly this table up here. Okay, so nice things happen when you're sort of given your information in the right format, but I will warn you, you're not always guaranteed that you can just kind of copy the table straight into your Tableau. Okay. Let's go ahead and label our rows. So the top row is your objective row. That always sort of has Z as its basic variable. The rest of our basis will be SL, SF, and SC. And so SL, SF, SC are going to show up there. And our initial solution we're going to choose our basis to be SL, SF, and SC, which means that we're going to set all of our original variables, XD, XT, and XC to be 0. They're non-basic. And so our initial solution is Z equals 0, SL equals 48, SF equals 20, and SC equals 8, and XD, XT, and XC are all 0. Okay, and that's because these ones are non-basic. Okay, and the basic variables, we can read them off from the right-hand side because when we set these ones to 0, essentially this part of the matrix is all being multiplied by zeros, and so it disappears. Okay, so now let's choose an entering variable. Looking at the objective row, I need to choose one of the columns that has a negative in it. Okay. Any of these three have a negative in it, so I could choose any of those columns. I'm going to choose the one with the most negative, so I'm going to choose XD as my entering variable. And I like to circle that column. Now let's go ahead and do the ratio test. And so I'm going to take the right-hand side divided by this, and 48 divided by 8 is 6, 20 divided by 4 is 5, and 8 divided by 2 is 4. So here I'll maybe write this as ratios. Okay, I maybe didn't leave myself quite enough space. Now I want to choose the smallest positive ratio, and that's going to be this last row here. And so my exiting variable is going to be SC. Okay. Now, let's go ahead. I'm not going to copy down my headers again, but I'm going to just sort of set up a Tableau right below this one and try to keep everything nicely aligned. Okay, so this is going to be my pivot row. I want to get a 1 here and zeros everywhere else in this column. I've got a 2 here, and so I need to divide this row by 2 in order to turn this 2 into a 1. Okay, so that'll give me, when I divide it by 2, that will give me a 1 here, 0 here. Yeah, we can move into fractions or kind of keep this as decimals. 1.5 divided by 2 is going to give me 0.75, 0.25, 0 divided by 2 is 0, 0 divided by 2 is 0, 1 divided by 2 is a half, and then 8 divided by 2 is 4. Okay, interesting thing is whatever you had for your ratio test over here, it's going to be what ends up right here. Okay. Now, I want to get a 0 here, a 0 here, and a 0 here. That's my goal for the rest of this. Now I can go ahead and fill in because I know my new basis is going to bring XD into SC spot. And so this is going to be the XD row. But then the other rows are going to be the Z row, the SL row, and the SF row. And so I'm going to expect to see those standard basis vectors in those columns still. And so this column is still going to be 1, 0, 0. The SL column is going to still be 0, 1, 0. The SF column is going to be 0, 0, 1, 0. Okay, so by filling those in, I save myself some work. Okay, now I want to cancel out this 4 and turn it into a 0. And so I can either use the old version or the new version with the 1 in it. Sort of up to you. I tend to turn this into a 1 and then use it because it's easier to say, okay, if I want to cancel out the 4, I take 4 times or -4 times this row, add it up. Okay. The only thing is then you're working from here to here instead of here to here. So either way. So I'm going to take -4 times this row, add it to this row, and the result is going to go into this row here. So -4, so this is 3 halves. -4 times that is going to be -3, plus the 2 is going to give us -1. -4 times this is going to be -1, plus the 0.5 or 1.5 is going to be 0.5. -4 times this is going to give us -2, plus the 0 is going to be -2. And -4 times this is -16 plus 20 is going to be +4 left over. Okay, be careful with these row operations. I'll say that we're only going to do these row operations for a short while, and then pretty soon we're going to let R take over for us doing the kind of computations here. Okay, now I want to get rid of this 8 up here, so I'm going to take -8 times this row, add it up to here. -8 times 0.75 is going to give us -6 plus 6 is 0. -8 times a quarter is -2 plus 1 is -1. -8 times a half is going to be -4. Add that up, and that's going to give -4 there. -8 times 4 is -32, plus 48 is 16. Okay. And then top row, I want to put it as 0 here. There's a 60 here. So I'm going to do 60 times this row, add it up to the top. So 75% of 60 is 45. Add that up to -30 gives us +15. Quarter of 60 is 15 plus -20 gives us -5 here. Half of 60 is 30, plus 0 is 30, and 60 times 4 is 240 plus the 0. Okay, so that is my result after pivoting. If you need to sort of slow down, do this by practice, okay? So next up, we repeat. So we ask the question, is it optimal? Actually, before we ask this, is it optimal? Let's ask the question, what's the solution? Well, now I can read off that Z equals 240, SL equals 16, SF equals 4, and XD equals 4. So we're making 4 desks here, no tables, no chairs, and we still have quite a bit of slack in our finishing hours and in our lumber. This is an LSL. But then let's see, XT equals XC equals SC equals 0. So we're making no tables, no chairs, and we have no slack in our carpentry constraint. Okay, we're using all our carpentry hours. Okay. Now let's think about what we're going to do next. Is it optimal? Well, we scan this row. We'll notice we got a lot of positive numbers now, but we still have one negative. And so we're going to circle this column here. And then we will do our ratio test. And so here we got a negative in this row, so 16 and negative. Just ignore anytime you have a negative in the pivot column. Don't even bother. 4 divided by 0.5. So think about 4 divided by half is actually maybe right. 4 divided by 0.5 equals 8. And 4 divided by 0.25 equals 16. Choose the smaller of the two, and which will be this one. And so this is going to be our next pivot row. Go ahead and see if you can do this next pivot. So pause the video, see if you can do this next pivot, and then I'll check in with you. Okay, so did you get it? Here's the tableau that I got after running it. I made a little mistake that I caught as I was checking it even. So it's real easy to make small mistakes as you're doing these row operations. Maybe copy down this one. I verified this one kind of on the computer just to make sure. Yeah, there's a lot of small places where you can mess up on these. The emphasis is not getting really good at doing these by hand, because pretty quickly we'll move on. But the reason why I want you to do these by hand at least a couple times is to get an idea of sort of what's going on underneath the hood. Okay, what's sort of going on with these row operations. Okay, so what's our new solution? Let's go ahead and read off our basic part. So Z equals 280 units of revenue, dollars, I think. SL equals 24. So we've still got 24 extra board feet of lumber. XC equals 8. So we're making 8 chairs. XD equals 2. So we're making 2 desks. And then the other variables are non-basic, and so they're all equal to 0. Okay, so the other variables are non-basic, and so they're all 0. Are we at an optimal solution? So we scan this top row. Are there any negatives still in the top row? And the answer is no. And so this is our optimal solution, which means that in order to maximize revenue, Dakota Furniture should make 8 chairs and 2 desks, no tables, and in the end, they'll have 24 units of lumber left over, 24 board feet of lumber left over at the end. So that was an example of the Simplex methods from start to finish. It'll be one of the few ones that we do by hand, but I wanted to give you an example where we're actually working it out by hand. So that's it for this video.